Welcome to the Study Gems. My name is Avinash Dwivedi and I'll be taking the second session on data structures and algorithm. And today I'll be covering two important topics, and that is binary search and recursion. So let's now go into the binary search. Binary search. Binary search is a searching algorithm which follows the divide and conquer strategy. And one important thing, perform binary search, our array must be sorted. So here I have an array which is sorted. So to perform binary search, we need two index pointers. One is low, which will be present at the starting point, and one is high, which is present at the end point. And suppose we want to find the element number 42, which is at the index 10. So our target is 10. So let us look how to perform binary search. So perform binary search, we will take low, high, and then we calculate mid, which is equals to low plus high by 2. So what is low? Low is 0. What is high? High is 14. And then we calculate mid. So what is mid? Mid is 0 plus 14 by 2, 7. So this is mid. So now listen very carefully. So the value we are searching for is 42. Check whether the value at mid is equals to 42. No, 42 is greater than 29. So 42 will be present at the right portion of the array. How? Because my array is sorted. So 42 will definitely be present at the this right portion of the array. So we can ignore the left half portion of the array. So how we will ignore the left portion of the array? By moving this low pointer to mid plus 1. So by moving this pointer, we will ignore the left portion of the array because we know that 42 will never be present at the left portion of the array because my array is sorted. So, so now what is low? Low is 8. What is high? High is 14. So for searching, we again calculate mid. So what is mid? Mid is 8 plus 14 divided by 2, and that is 11. So this will be my mid. So again listen carefully. What value we are searching for? We are searching for 42. Now check whether the element present at mid is 42. No, so 47 is greater than 42. This means that 42 will be present at the left portion of the array. This time 42 is present at the left portion of the array. So we can ignore the right portion of the array. So how we will ignore the right portion? By moving the high pointer to mid minus 1. So what is low? Low is 8. What is high? High is 10. So now for searching, we will again calculate mid. So what will be mid? It will be 8 plus 10 by 2, and that is 9. So this will be my mid. So now again, what I am searching for? I am searching for 42, but this is 36. So 42 is greater than 36. So my answer will present at the right portion of the array. So now again, we can ignore the left portion of the array by moving the low pointer to mid plus 1. So now what is low? Low is 10. What is high? High is also 10. So now for searching, we will again calculate mid. So what is mid? Mid will be 10 plus 10 by 2 is equals to 10. And now we are searching for 42. So check whether the mid is 42. Yes, mid is 32. So we have successfully found our target element and then we will return the index 10. So now look, how many steps does binary search takes? Binary search takes 4 steps, means it takes 4 operation to search this element. if we have performed linear search. So linear search would have taken total 11 steps to find this 42, but binary search has only taken 4 operations, that is 4 steps. So this is binary search and its time complexity is log n. So let us look at how binary search is performed if we took our target element which is not present in our array. So here I have taken 40 and 40 is not present in this array. So let us look how binary search will be performed. So again we will take two index pointer. One is low at starting point and one is high at the end point. So what is low? Low is 0. What is high? 14. Then again we will calculate mid. It is 0 plus 14 by 2 is 7. So this will be my mid. So what value we are searching for? We are searching for 40. 40. So check whether the mid is 40. No, mid is 29. So 40 is greater than 29. So our answer will be present at the right portion of the array. So we will ignore the left portion and move this low pointer to mid plus 1. So what is low? Low is 8. What is high? High is 14. Again we will calculate mid. So what will be my mid? Mid will be 8 plus 14 by 2 and that is 11. So this will be my mid. So again what value are we searching for? 40. So check whether it is 40. No, it is not 40. It is 47 and 47 is greater than 40. So definitely 40 will be presented in the left portion of the array. So we will ignore the right portion and move high pointer to mid minus 1. Then what is my low? 8. What is my high? 10. So again we will calculate mid. So mid will be 8 plus 10 by 2 and that is 9. So this will be my mid. Again check whether the mid is equals to 40. No, it is not. So 40 is greater than 36. So my answer would be at the right portion of the array. So we will ignore the left portion and move this low to high. So now, what is my low? Low is 10. What is my high? High is 10. So again, we will calculate mid. So what is my mid? Mid is 10 plus 10 by 2 and that is 10. So now check whether my mid is equals to my target. No, it is not equals. So 42 is greater than 40. So definitely my answer would be, if an answer would be in the left portion of the array. So we will ignore the right portion of the array. So how we will ignore the right portion of the array? By moving the high to mid minus 1. So we'll move high to mid minus 1. So my mid is 10. So my low would again be 10 and my mid will be mid minus 1 and that is will be 9. But wait, my low has become greater than high. So we will at this point we will stop searching because at this point we will know that this element is not present in our array. Let us now look at the algorithm of binary search. So what we keep doing in binary search, we keep finding mid. So we will use a while loop. So how we find mid? We find mid using low plus high by 2. So after finding mid, what we do? We checks whether my middle element is equals to the target. So we checks if my middle element is equals to target, we will return the index. And if my middle element is less than target, so if my middle element is less than target, it means that my target element will present at right portion of the array. So we can ignore the left portion. How we will ignore? By moving this low pointer to mid plus 1. Yes, so we will move low pointer to mid plus 1. So we can write low is equals to mid plus 1. And now if my mid is greater than target. So if my mid is greater than target, so my answer would definitely be presented left portion of the array. So we can ignore the right portion of the array. How we will do it? By moving this high pointer to mid minus 1. Yes. So we can write that high pointer is equals to mid minus 1. So until we keep doing this, until my low is than high, till my low is less than equals to high, we will keep doing this. And when my low becomes greater than high, if my target element is not present in this array, at that point, what we will do? We will return a minus 1. So this is the algorithm of binary search. So let us now go into the code editor and code this algorithm. So I am at my code editor. So let's now quickly write the code for the binary search. I'm doing it in C++. If you know the algorithm, you can do it in any language. int main. So now let's write the binary search. So what all things we are pass and so array, then what our target. Now each time what we do, we calculate. So we need to create two pointers. Low start low initially was at 0 and the high that is at size. So we are r dot size minus 1. So this will be the last index. So high will initially be at the last index. Then what? At each time we calculate mid, which is equals to what? Low plus high by 2. Then we check if the ARR of mid is equals to my target. So if it is equals to my target, what? I will return the index here. Index is mid. But if my ARR of mid is less than target, what? We need to ignore the left portion. So left pointer will be moved to mid plus 1. Else I is equals to mid minus 1. We will ignore the right portion. And you will keep doing this until low is less than is too high. What if no element is found? Then what? Then we will return minus 1. So let us now quickly check. Let's create an array. Let's create the same array. 3, 6, 8, 12, 14, 17, 25, then 29, 31, 36, 42, 47, 53, 55, then 62. Such a long array. Then we will perform the binary search. So you will directly print the binary search. Okay, so let's check for 42. What this will print? So this says print 10. So 10 is a 42 is a 10th index. Now let us also check for 0. Let's do like 3. So yes, so 3 is at 0th index. So let us now write an last index element 62. So 14, yes, so 14th index. So let us now write an element which is not present in this array. And look what it gives 40. So returns -1. So let us now quickly copy this and paste this in our question. So what question says? Given an array nums which is sorted in an ascending order and an integer target, return a function. So target in nums, if target exists, then we need to return its index. Otherwise, we need to return -1. That is the same thing we were doing. So let's paste it here. Same code. We don't need to change anything. Just we need to return binary search, and we will need to pass the nums array and target. This should work. So yes, this is running. So let's now submit this. So yes, it is working for all test cases. So after completing binary search, let us now go into our second important topic, and that is recursion. Before going to recursion, let us first look at how a function call is made, because a recursion is a function call only. So here I have an example program. In this program have a main function, and this main function is calling another function named func. And as we know that every program begin its execution from the main function. So as this main function will gets executed, this main function got pushed onto the system call stack, and then it will execute the first statement, then the second statement, and once it executes this third statement, the function func will be pushed onto the system call stack, and then it will execute the first statement, then the second statement, the third statement. And once this function func is completed, it will get popped out of the system call stack and the control is returned to the previously called function. And here it is the main function. And then it will execute this arithmetic operation of -2 with this function, and then it will execute this fourth statement, and the main function will be completed and get popped out of the system call stack, and our program ends. So from this, these are the points to remember, and that is whenever a function is called, it is pushed onto the system call stack, and once the function completes its execution, it gets popped out of the system call stack and the control returns to the previously called function. Let us look at the general form of recursion. So recursion is a function calling itself. So if function call itself, it is called as a recursive function. And one important thing in recursion, here you can see it has a base condition. So a recursion must have a base condition. So in order to terminate the recursion, otherwise this function will keep on pushing into the stack and ultimately give us the stack overflow error. And these are the points that I have just told, that is function that call itself is called a recursive function. And an important aspect of recursion is the base condition, which ensures termination. And without it, the function will call itself indefinitely, leading to a stack overflow error. Let us look at an example of recursion. So in this example, I'll be telling you the tree tracing of this example. So what is a tree tracing? The tree tracing helps us to visualize the recursion. So by using this tree tracing, you can understand how actually all the function calls are made during the recursion. So let's begin executing our program. So again, the program will begin its execution from the main function and it is pushed onto the system call stack. And then this 3 is assigned to x, and this function is called as a parameter t, and it is called and it is pushed onto the system call stack. And since this 3 is greater than 0, then what it will do? It will print 3, yes. And then what it will do? It will call this function with parameter n minus 1, and that is 2, and it is pushed onto the stack. And since 2 is greater than 0, what it will do? It will print 2, and then it will call this function that is 2 minus 1, that is func 1. This is called and it is pushed onto the stack. And since 1 is greater than 0, what it will do? It will print 1. And then it will call 1 minus 1, that is 0. So func0 is called, it is pushed. Now, see, this condition is become false since 0 greater than 0 is false. So, this func0 is now completed. So, what? Since it is completed, it will return and it will pop out of the stack. Since func1 was actually here, func1 was also completed. So, it will also return to func2 and it will pop out of the stack. Since func2 was also here, it will return and it will be popped out. And func3 was also here. So it will return and popped out to the main function. And the main function is also popped out as it is completed. So here is our output, and that is 3, 2, and 1. So let us look at another example of recursion. In this example, I'll be printing this statement after calling this function. So let's begin executing our program. Our program again will execute from the main function and it is pushed. Then this 3 is assigned and this called with parameter 3 and it is pushed. And since 3 is greater than 0, what it will do? This will call this function func with a parameter 2 and it is pushed into the stack. And now since 2 is greater than 0, this func2 will call this function func with the parameter 2 minus 1, that is 1, and it is pushed onto the stack. And now func1 was, since 1 is greater than 0, so now this func1 will call with this function with parameter func1 minus 1, that is 0. And now this condition becomes false. And since this condition becomes false, this func0 is now completed. And since it is completed, it will return. It will pop out of the stack. Now, since func1 was here, so what it will do? It will print 1. So now func1 is completed, it will return. Func2 was also here, so it will print 2 and it will return. Since func3 was here, so what? It will print 3 and it will return to the main function. When the main function is completed, it will be popped out. So this is the output of this example, and that is 1, 2, and 3. So let's now quickly code both of the example in our code editor and look at the output. So I'll be doing it in C++. String include value stream using main string main. So let's now write a recursive function. Integer n. So what we are doing, if this n is greater than 0. So if this is greater than 0, what we are doing? We'll print n. Print n. And then what we will do? We will again call this function with parameter n minus 1. So let's now run this with the parameter. Let's now run it. Yes, so our output is 3, 2, and 1. So let's now quickly copy this, paste it here. Let's change this name as func2. So in the second example, what we are doing? We were just printing this statement after calling this function. So now let's call this. Let's look at the out. Yes, so now output become 1, 2, and 3. So let us also try it with different inputs. This 3, let's give it 5. Let's run it. Yes, so it is 1, 2, 3, 4, and 5. And when it is called with the example1 function and we run it, it gives us 5, 4, 3, 2, 1. Let us now compare both the examples that we have just coded. So look at this example. So in this example, what we are doing, we are firstly printing and then calling the function. So we are printing and then calling. We are printing and then calling. We are printing and then calling. But in this function, since this print statement is written after this function call, so what we are doing, we are calling then we are calling, and then we are calling. Then we return and print, return and print, return and print. So from these two examples, what we notice that this statement is executed when this function completes its exploration. So this 3 will only get printed when this function 2 is completed, and this 2 is printed when this function is completed, and this one is printed when this function is completed. So that's why when it's returning, then it's print. So from these two examples, what we can conclude? We can conclude that if this print statement is written above the function call, then it is executed at the calling time. And if this print statement is written after the function call, then it is executed at the returning time. So let us now again look at the general form of recursion. So from the previous two problems, what we learned? We learned that the statements written above the function call is executed at the calling time, and the statements written after the function call is executed at the returning time. And one more thing, that the portion above the function call is known as ascending phase of recursion, and the portion below the function call is known as the descending phase of recursion. This is the important point to note. I have just added extra third point, that in a recursive function, the code before the recursive call runs when the function is called, and the code after it runs when the function returns. So let us now compare recursion with loops. So what is loops? Loops are the repeating statements. And what is recursion? Recursion is also repeating statements. So what is the difference between recursion and loops? So the main difference between recursion and loops is that the loops only have this ascending phase, but the recursion have both this ascending phase and the descending phase. So in loops, we can only go at one direction. So whenever we execute a loop, we only we only go same direction. We cannot return like the recursion. Let us now calculate the time complexity of this previous program. So to calculate the time complexity of this program, we assume that the time taken by this function is Tn. So if the time taken by this function is Tn, then the total time Tn should be the summation of time taken by all the statements inside this function. So for this function, this if statement will take 1 unit of time, print statement will take 1 unit of time, and this function, this recursive function will take Tn minus 1 time. So Tn will be the summation of each statement. So now let's write the recurrence relation of this function. So if n is greater than 0, so our recurrence relation will be Tn minus 1 plus 1. So this plus 1 is, if we can take plus 1 for the constant time. And if n is equals to 0, so we can see that if n is equals to 0, this condition becomes false. And then this function will take 1 unit of time. So let's now solve this recurrence function to get the time complexity. So we have Tn is equals to Tn minus 1 plus 1. Let's name it as equation 1. Now we need to find the time. Now we need to find the value of Tn minus 1. We can get the value of Tn minus 1 from equation 1. We get Tn minus 1 is equals to Tn minus 2 plus 1. And now we can put this value in equation 1 again. We get Tn is equals to Tn minus 2 plus 2. Name it as equation 2. Now we need to find the value of Tn minus 2. And again we can get the value of Tn minus 2 from equation 1. We get it as Tn minus 3 plus 1. And now we can put this value in equation 2. We get Tn is equals to Tn minus 3 plus 3. Now let's name it as equation 3. And we will keep doing that till how much time? Let us suppose let it take k times. So for the kth time, we get the time complexity as Tn is equals to Tn minus k plus k. Let's name it as equation 4. So this recurrent function will keep on decreasing the value of n minus k until it reaches 0. When it reaches 0, we get n minus k is equals to 0 and we get k is equals to 1. Now we will put this value of k is equals to 1 in equation 4. We get Tn is equals to T0 plus n. And now we know that the value of T0 is 1. So we successfully solved this recurrence relation. We get Tn is equals to 1 plus n. So we get a time complexity as fig of n. Let's now look at this problem, and that is sum of first n natural numbers. So we already have some methods to solve this problem, and that is using loops and using the formula of nn plus 1 by 2. But today, I'll not be showing you how to do this using these two methods. Instead, I'll be showing you how to do this using recursion. So, to do this problem using recursion, we need to first write the recurrence relation of this problem. And once we write the recurrence relation, coding that particular problem becomes very easy. So let's now write the recurrence relation of this problem. So what we know? We know that sum of one natural number is 1. Let's name it as equation 1. Sum of two natural number is 1 plus 2. Sum of three natural number is 1 plus 2 plus 3. And similarly, we can write that sum of n minus 1 natural number is 1 plus 2 plus 3 till n minus 1 terms. And similarly, we can write sum of n natural number as 1 plus 2 plus 3 till n terms. And if we look at this portion, what is this? This is sum of n minus 1 natural numbers. So now we can write that is sum of n natural number is sum of n minus natural number plus n. Let's name it as equation 2. So let's now write the recurrence relation. So if n is greater than 1, we can write the equation 2. That is sum of n minus 1 natural numbers plus n. And if n is equals to 1, this will be our base condition. And if n is equals to 1, what we can write from equation 1? It is 1. So we have successfully written this recurrence relation, and now we can easily code this problem. So let's now quickly go into our code editor and code this problem. So now we are in our code editor. So let's write down the code of this recurrence relation, and that is sum of first n natural numbers. So I'll be doing it in C++. Name space standard int main. Now let's write our code. So return type is integer. Look at the relation sum integer n. Now look at the relation what it says. It says that if n is 1, then what? We will return 1. Else what we will do? We will return sum of n minus 1 natural number plus n. Look how easy it is to write the code if you know the recurrence relation. So let's now check it. Two, 3, 4, and then 5. Yes, it is working fine. So let's now quickly copy this and paste it in our question to check whether it is working for all test cases. So sum is our function, so we will return sum pass n. So let's compile it. Yes, it is working fine. So let's submit it. It will definitely pass all the test cases. Yes. So let us now look at this problem, and that is factorial of a number. So we already have a method to do this problem, and that is using loops. But today I'll only be telling you how to do this using recursion. So let's now write the recurrence relation of this problem. So what we know? We know factorial of 0 is 1. Let's name it as equation 1. Factorial of 1 is 1. Factorial of 2 is 1 multiplied by 2. Factorial of 3 is 1 multiplied by 2 multiplied by 3. And similarly, we can write that factorial of n minus 1 is 1 multiplied by 2 multiplied by 3 till n minus 1 terms. Similarly, we can write factorial of n as 1 multiplied by 2 multiplied by 3 till n terms. And if we look at this portion, what is this? This is factorial of n minus 1 terms. So now we can conclude factorial of n is factorial of n minus 1 terms multiplied by n. Let's name it as equation 2. Let's now write a recurrence relation. So what should be our base condition? Yes, this equation 1 should be our base condition, and that is if n is equals to 0, what we get? We get 1. And if n is greater than 0, this equation 2 we get. And that is factorial of n minus 1 terms multiplied by n. So we have successfully written the recurrence relation of factorial of a number. So let's quickly go into our code editor and write the code of this problem. So let's now write the code of factorial of a number. So integer fact int n. Look at the relation, what it says. It says if n is 0, then what? We will return 1. Else what? We will return factorial of n minus 1 multiplied by n. See how easy it is to write if you know the recurrence relation. So let's now change this to check whether it is working or not. Yes, it is giving correct output. So let's copy this and paste it here in our problem. Check whether it is working for all test cases. Let's return factor. Yes, it is working fine. Let's submit it. Yes, it is working for all test cases. So let us now look at this problem, and that is nth Fibonacci number. I hope you know that what is a Fibonacci sequence. So it is a sequence in which if we take particular term, then that term must be the sum of previous two terms. So we have various methods to solve this problem. So we can solve this using loops, using memoization in the dynamic programming, using bottom-up approach of dynamic programming, and using matrix exponentiation. But I'll only be telling you how to do this using recursion. So let's now write the recurrence relation of this problem. So what we know? We know that Fibonacci of 0 is 0. Let's name it as equation 1. Fibonacci of 1 is 1. Let's name it as equation 2. Then Fibonacci of 2 is the sum of previous two terms, and that is 1 plus 0, and that is 1. Fibonacci of 3, the sum of previous two terms, that is 1 plus 1. is 2. Fibonacci of 4, the sum of previous two terms, and that is 2 plus 1. Then Fibonacci of 5 is the sum of previous two terms, and that is 3 plus 2, and that is 5. So what we can write, that this Fibonacci of 5 is the sum of this Fibonacci of 4 plus Fibonacci of 3. So this is the sum of previous two terms. So now we can conclude Fibonacci of n term is Fibonacci of n minus 1 terms plus Fibonacci of n minus 2 terms. So let's name it as equation 3. So now we can write a recurrence relation. So if the n is greater than 1, what we can write? So we can write from this equation number 3, and that is Fibonacci of n minus 1 plus Fibonacci of n minus 2. And if this n is less than equals to 1, so look at this two equation. So if it is less than equals to 1, so for 1 we are getting 1, for 0 we are getting 0. So for n we will get n. So we have successfully written the recurrence relation of this problem. So let's quickly go into our code editor, write the code of this problem. So now look at the relation. So let's write it integer Fibonacci integer n. Look at the relation, what it says. If n is less than equals to 1, what we will do? We will return n. Else what we will do? We will return Fibonacci of n minus 1 plus Fibonacci of n minus 2. See how easy it is to write if you know the recurrence relation. So let's now change this. Run it. Yes, it is given. It is running fine. Let's copy this and paste this in our problem. Check whether it is working for all test cases. So we will return Fibonacci n. So let's check this, compile and run. Yes, it is giving correct output. Let's submit it. Yes, it is working for all test cases. So let us look at this problem, and that is sorting a stack. In this problem, we will be given a stack, and our task is to sort this stack in an ascending order such that the greatest element is at the top and the smallest is at the bottom. So to do it, what we will do, we'll pass this stack in this function. And what this function will do, this function will sort this stack. So look here, 3 is greater than 2, 11 is greater than 3, 32 is greater than 11, and 41 is greater than 32. So this stack is sorted. So if we pass this function over this stack, this function will sort the stack. So this is the problem. So we are given a stack and our task is to sort it such that the top of the stack has the greatest element. So one way of doing this question is, firstly we pop all elements and push it in an array and then sort that array, and after sorting we push all elements of array one by one to our stack to get our answer. But we'll not be doing it that way. We will do this question without using any data structure, and that is using recursion. So let's now look into it. But before going to that problem, let us first see this problem, and that is insertion in a sorted stack. So you will soon know why I am doing this question first. So in this problem, we will be given a stack and that is already sorted. So look here, that 2 is greater than 1, 4 is greater than 2, 5 is greater than 4. So this stack is already sorted. So our task is to put this 3 in this stack such that after putting this 3, this stack should remain be sorted. So how I will do it? So we will do it by passing this stack over this function, this insert sorted function. And what this function will do, this function will put 3 in its correct position. So after putting 3, this stack will be remain sorted. So this is the problem. So given a stack of integers already sorted in an ascending order from bottom to top, and our task is to insert an integer n while maintaining the sorted order. So let's now understand how to put this 3 in its correct position, and that is between 2 and 4 through this animation. So put this 3 between 2 and 4. Firstly, we need to pop this 5 out, and then we need to pop 4, and then we need to push 3, and then we will push 4, and then we will push 5. Let's again see. So to put this 3 in its correct position, we pop 5, we pop 4, then we push this 3, then we push 4, and then we push 5. So let us now again look at this, but this time we will observe. So what we were checking? So we are checking, does the top is less than n or otherwise? So now look, does the top is less than n? No. So we store the top in a temporary variable and we pop. Does the top is less than n? No. So we store the top in a temporary variable and we pop. So now look here. So if the top is not less than n, what we were doing? We are storing the top in a temporary variable and we pop. Now again look at this. Does the top is less than n? Yes. So what we will do? We'll push. So now look here. If the top is less than n, so what we are doing? We are pushing n, and now we have reached our base condition. So once we have reached our base condition, we will return. So now look here, we will push this 4, we will push this 5. So now in returning time, what we were doing? We were pushing the temp. So we have successfully returned this insert sorted function. But wait, let us again look at this example, but we will take a different example, that is n is equals to 0. So look, the top is less than n, we pop. Does the top is less than n? No, we pop. Does the top is less than n? No, we pop. Does the top is less than n? No, we pop. Does the top is less than n? Wait, there is no top. So we need to add one extra condition over here. That is, if the stack is empty, then we push. So we will push, and then we will push this one, push this 2, then 4, and then 5. So we have successfully written this insert sorted function. And once we have successfully written this function, it is very easy to code it. So let's go in our code editor and quickly code it. We are in our code editor. So let's now code this function. So the main function. So let's now write this function. So what this function returns? So this is returning nothing. So void. So insert sorted function. So what are the parameters? We are passing a stack which has integer. Let's name it st, and we are passing it as a reference variable. And we need to push this n in its correct position. So int n. So what we were doing? So every time we keep checking if the stack is empty or the top of stack is less than equals to n. So we keep checking this. And if this is not true, then what we did? Look, we store the top in temporary and then we pop. So we store the top in a temporary variable and then we pop, and then we do a recursive call on insert sorted function, and we pass stack n. So now we keep doing this until we reaches this base condition. And once base condition is reached, then what we do? We push we push the n, and then we return. So after returning, we go at the returning time, and at the returning time, what we did? We push this stem. So let's now. So at the returning time, we push the temporary variable. So yes, so we have successfully wrote this function, the insert sorted function. So let's now quickly check this. So in main function, let's create a stack. Let's now push some elements. Let's take the same example we did. So 2, 4, and then 5. So let's now insert. So insert sort in stack st. Let's again insert 3 as our example. So before performing this, let us print our stack using the print stack function. So let's now write this print stack function. So print stack of integers st. So now how do we print the stack? So while so what how do we print? So we first print the top element with the so we print the top element and then we pop that top element. So we will keep doing it until the stack is empty. So till keep doing this until the stack, so till stack is not empty, then we do this. So let's also mark pointer to keep the top and the bottom element. So to know which is one is top element and bottom element, so we will also print the top element. This will point towards the top element, and again bottom element is entered at last. So print the so this would point towards the bottom element. So we have wrote the print stack function. So let us now also print the stack after performing the insert sorted function. Stack stack. Yes, we will print the stack. So let's now run it. So what is this? So what error it is giving? Yes, we have not written ENDL at line 23. This line 20 it is giving error CPP 1020. So at the line number yes, the line number 10 we have not written L. Let's know. Yes. So now look. So so before performing the insert sorted function, this was our step, the top element and the bottom element. Once we inserted 3, So this 3 is inserted between 4 and 2. Yes. So we have successfully wrote this insert sorted function. So after solving the previous problem, let us look at our original problem, that is sorting a stack. So now look how the sorting is done in a stack. So a sorting is done. So firstly we pop the top element, that is 41. Then we pop 3. Then we pop 32. Then we pop this 2. Now wait. Now listen very carefully. So a stack with size 1 is already sorted, isn't it? So now what we will do? We will push this 2 in this stack, and while pushing this 2 in this stack, we will put this 2 in its correct position such that after insertion of this 2, this stack should remain be sorted. Isn't this is what we are doing in our previous problem? Yes. So what we will do? We will pass this 2 in our insert sorted function. Yes. So what this function will do? This function will put this 2 in its correct position. So now look how it is done. So to put this 2 in its correct position, this function will pop 11. Then we'll push 2 and then we'll push 11. So now we will pass this 32 in this function. So how it will do? Directly push 32 because 32 is greatest. So now look, now we will pass this 3 in this function, and this function will put this 3 between 11 and 2. Now look, so 11 is popped out, sorry 32, and now 11 is popped out, now 3 is pushed, now 11 is pushed, now 32 is pushed. Now we will again pass this 41, this function. So what it will do, we directly put 41 in the top. So after this, now look, our stack is successfully sorted. So let us now again look how the sorting is done, but this time we will closely observe the sort stack function. So what we were doing? So we were checking, does the size is equals to 1 or otherwise? So now check, does the size is 1? No. So what we do? We store this 41 in a temporary variable and we pop. Does the size is 1? No. We store this 3 in a temporary variable and we pop. Does the size is 1? No. Store it in temporary variable, pop. Does the size is 1? No. Store it in a temporary variable and then pop. So now look, if size is not is equals to 1, so what we were doing? Storing the top in a temporary variable and we pop. So now again look, does the size is equals to 1? Yes. So now what we will do? Nothing. We will do nothing. We will just return. So now once we have reached our base condition, now we will return. So while returning, what we were doing? While returning, we were passing this 2 in our insert sorted function. Yes. So what this function does? This function put this 3 in 2 in its correct position. So now look how it is done. So now 2 is placed in its correct position. Now 32 is placed in its correct position. Now 3 is being pushed in its correct position. Now 41 is placed in its correct position. So now look, in returning time, what we are doing? We are passing all these temporary variable in our insert sorted function. Yes. So we are passing this temp in our insert sorted function. So we have successfully wrote our insert sort function. So once we have observed this, we can easily code it in our code editor. So let's now quickly go into our code editor and quickly submit this problem. So now we are in our code editor. So let's now code this observation. So we have already coded this insert sorted function. So let's now code this sort stack function. So our return type is void. So sort stack. What are the parameters? Only one parameter, and that is stack of integer. So what we were doing to sort the stack? So each time we were checking if the size is 1. So if the size is not 1, what we were doing? We were we were storing the top variable. So we are storing a top in a temporary variable. So st dot top, and we we pop the top element, and then we do a recursive call on sort stack. So we keep doing this until size is equals to 1. So when size is equals to 1, what we do? We do nothing. We just return. So if size is equals to 2, we will return. So uh, when we reaches our base condition, we returns. And at returning time, what we did? At returning time, we call this insert sorted function. Insert sorted, we pass stack, and this temp is the parameter. So let's now quickly change this stack example and take what we have did before. So that was, firstly we need to push 11, then 2, then 3, then sorry, 2 after 2 is 32, then 3, and then 41. So this was our stack. So we will print this stack before performing the sort. So let's now write our sort stack function, and there will be no parameter, and we will print it after sorting. So let's now check if there is any error. Yes, so it is showing error that size was not declared. Yes, we have not. We have to write st dot size in function. So let's now again run. Yes, so it has. So initially our stack was this. So what, the stack was already sorted. Mm, oh, sorry. Actually, we have not passed it as a reference. So let us now again print this. So look, yes, now it is sorted. So this was our initial stack, and after that it became 2, 3, 11, 32, and then 41. So our stack is sorted. So let's now quickly copy these two functions. Just copy it and let's paste this in our this problem to check whether it is working for all test cases. So look here. So a class of sorted stack. So a sorted stack class is defined, and inside that class we have stack ints in the void sort function. So this is how they have defined it. So to sort this stack, we need to call the we need to call our sort stack method. Inside this, we need to pass this stack. So to access this stack, so we need to write sorted stack s. I think this should work. Yes. So this is given the correct out. So let's now submit to check whether it is working for all test cases. Yes. So all test cases are passed. So we have successfully written this code. So look at this. So we have successfully written this code through our observations of this. So how simple. So it takes time, but still we wrote it and we understood this problem very well. So let us now look at this problem, and that is reversing a stack. So in this problem, we will be given a stack and our task is to reverse it. So in order to reverse this stack, what we will do? We will pass this stack this reverse stack function. And what this function will do? This function will reverse the stack, and that is 41 is now come to bottom and this 11 is now gone to top. So what is the problem? So our problem is that we have given a stack and our task is to reverse it. So now look how the reversing is done in stack. So firstly, we pop the top element, that is 41, and store it in a temporary variable. Then we pop 3, then we pop 32, then we pop 2. Now wait, if when the size is equals to 1, now we will push this 2, but while pushing this 2, we will push this 2 at the bottom. Why are we doing it? So if we keep pushing every element at the bottom, then ultimately at finally our stack will be reversed. So let's now look at. So now push this 2 at the bottom. So to push this 2 at the bottom, we need to pop 11. Then we push this 2. Then push 11. Now we push this 32 at the bottom of the stack. So to do so, we need to pop 11. Then we pop 2 and then we push 32. Then we push 2. Then push 11. Now again, now we will push this 3 at the bottom. So look, we will pop 11, we pop 2, we pop 3, and then we push this 3. Then we push 32. Now we push 2. Now we push 11. Now again, we will put this 41 at the bottom. So again, we need to pop all these elements. Yes. And then we push this 41. Then we push 3. Then we push 32. Then we push 2. Then we push 11. So now look, our stack successfully reversed. So let us now look in how to reverse a stack, but this time we will observe each and every step. So what we were doing, we will keep popping the elements of the stack until its size is 1. So what we checks each step, we check does the size of the stack is 1 or otherwise. So let's now look. Does the size of this stack is 1? No. So we put this in temporary variable and we pop. Does the size of the stack is 1? No. We pop. Does the size of the stack is 1? No. We pop. Does the size of this stack is 1? No. So we pop. So look here, what we were doing. If the size of the stack is not 1, then what we did? We store the top in a temporary variable and we pop. So now again look here. So does the size of the stack is 1? So yes. So what we will do? We'll do nothing. We'll just return. And once we have reached our base condition, we will return. So now, so now look. So once we return, we will push this 2 at this stack. But while pushing this 2, we will push this 2 at the bottom of this stack. So to push this number at the bottom, we will pass this to this function, that this insert bottom function. So this insert bottom function will put this 2 at the bottom of this stack. So at the return time, we call this insert bottom function. So pass this temporary variable over this insert bottom function. So let's now look how this insert bottom function works. So how does this function works? So this function just keeps popping the elements until it is empty. So at each and every step it checks whether the stack is empty or not. So if the stack is not empty, it just pops out the element. So what it checks? It checks does the stack is empty or otherwise. So now look here. Does the stack is empty? No. So it pops, then it pushes 2, and then it returns and push 11. So now again look with this 32. So we pass this 32 in this insert bottom function at the return time. So now look. So does the stack is empty? No. We pop. Does the stack is empty? No. We pop. So now look what we were doing. If the stack is not empty, we were storing the top in a temporary variable and we pop. So now again look. So does the stack is empty? Yes. So we push the 32. So now again look. So we check the so if the stack is empty, what we were doing? We were pushing n. So we pushes n. So once we reaches our base condition, we return. So look what we do in return. We push this 2. We push this 11. So what we are doing in return time? We push the temp. Yes. So we are pushing the temp. So now again look with this 3 to understand more clearly. So now to push this 3 at the bottom, we need to pop this all out. So we keep popping until the stack is empty. So we pop this, then we pop 2, then we pop 32. So we keep popping the stack until it is empty. And then when it is empty, then we pushes this n. So we pushes and now we return. And when we return, we push this temporary. So 32, then 2, then 11. So now again look. So to push this 41 at the bottom, pop 11, then 2, then 32, then 3, and then we pushes this 41. Then we push 3, then 32, and then 2, and then 11. Yes, so our stack is now successfully reversed. So we have successfully written this observation, and now we can easily write the code to reverse a stack. So let's now quickly go into our code editor and write the code for reversing a stack. So again, we are in our code editor. So let's now write the reversing of a stack using this observation. So let's now first write the insert bottom function. So what it returns? It returns nothing. So bottom. So what we are passing? We are passing the of integers st, and don't forget we'll pass it by reference, and we push this and the bottom. So what you are doing? Each time we were checking if the stack is empty. So if it is not empty, what we are doing? We are storing the top in a temporary variable. Then we pop the top element, and then we call our insert bottom function and pass n. So, so this we're doing. So if the stack is empty, then we push n. So if the stack is empty, we pushes the n and we return. So when we reaches our base condition, after that we return. So what we do at return time? So we push the temporary variable. So we will push this temporary variable at a return time. So we have successfully written our insert bottom function. So let us now write our reverse stack function. So stack integer, we'll pass it as a reference with other parameters. So what we are doing, we are checking if the size of the stack is 1. So if it is not, what you are doing? We were storing the top and storing the top in a temporary variable, and then we pop the stack, then we call the reverse stack function. We do a recursive call. So when we reach this condition, base condition, what we do? We do nothing. We just return. And once we reaches our condition, we return and perform is the returning thing. That is, we will insert the element at the bottom. Yes, so now we have successfully written the reversed. So let's now quickly bring the print stack from previous problem. Print it. Also, we will bring this also. Okay, so our stack was this only. We will print this stack. We will perform this reverse. So let's now look. Let's now run our code. Yes, so look. So before performing the reverse stack function, so this was stack, and after performing it, yes, a stack is reversed. So let's now quickly copy this. These are only two functions required. And let's now go to this problem and paste it here. So let's now check whether this works for all test cases. We will perform a reverse stack st. Let's compile and run. Is giving an compilation error at 35. So I have not written C. Again, it is giving the reverse stack at 35. ST was not declared in. Sorry, it is capital S. So let's now. Yes, so this is giving the correct output. So for 457, it should be 754. Let's now submit it. Yes, so it is working for all test cases. So before going to next question, let us understand the difference between subarray, subsequence, and subset. So the subarray is contiguous part of an array, and you cannot change the order of elements in a subarray. A subsequence is derived by deleting some elements from array without changing the order, and the elements don't need to be contiguous. And a subset is any possible selection of elements from the array, and in subset, order doesn't matter. So let us now again understand the difference between a subarray, a subsequence, and a subset using this example. So let's now start with the subarray. So what we know about the subarray, that is, it can be contiguous, but its order matters. So let's now start printing the subarray. So 1 can be a subarray, 2 can be a subarray, 3 can be a subarray. Can 1 2 be a subarray? Yes, as it is contiguous and it is a same order this array. Can 2 3 be a subarray? Yes. Can 1 2 3 be a subarray? Yes, as it is contiguous and its order is same as that of the array. Can 1 3 be a subarray? So look, 1 and 3, its order is same. But wait, it is not contiguous. So 1 3 cannot be a subarray. Let's now look at subsequence. So what we know about subsequence? That it can be non-contiguous, but its order matters. So let's now print the subsequence. So 1 can be a subsequence, 2 can be a subsequence, 3 can be a subsequence, 1 2 can be a subsequence, 2 3 can be a subsequence, 1 2 3 can be a subsequence. Now look, 1 3, can 1 3 be a subsequence? So 1 3 is non-contiguous and its order is same. So yes, 1 3 can be a subsequence. So look, that's the difference between a subarray and a subsequence. That that subsequence can be non-contiguous, but subarray must be contiguous. Let's now look at the subset. So what we know about subsets? So subset can be non-contiguous and its order doesn't matter. We can take it in any order. So let's now start printing the subset. So 1 can be a subset, 2 can be a subset, 3 can be a subset, 1 2 can be a subset, 2 3 can be a subset, and 1 2 3 also can be a subset. Now, can 1 3 be a subset? Yes. But wait, what is the difference between a subsequence and a subset? As all the elements you can see everything is similar. So let's now look at 3 1. So can 3 1 be a subsequence? Now look. So 3 1 is non-contiguous. But look, firstly we have written 3. 3 and 1. So its order is changed. So 3 1 cannot be a subsequence. But if we look here, so 3 1 can be a subset because in subset order doesn't matter. So look, that's the difference between a subsequence and a subset. And yes, and for the subarray, yes, it cannot be because it is non-contiguous and its order also is not the same as the given array. One important thing, and that is if in a question of subset, it is said that the subset must not contain the duplicates. So duplicates mean 1 3 and 3 1 both are treated as same thing. So instead of printing subsets, we can print the subsequence in that question because printing subsequence is much easier because in subsets these combinations are also involved. So if in a question of subsets it is said that its answer must not contain duplicates, then we can print the subsequence at that time. Let us now look at the method 1 for printing the subsequence. And that this method is called as the pick and not pick method. So in this method, we go to each index starting from the beginning and will think whether I should pick that index in my answer or not. Now look at this error. Firstly, we move to this index and will think whether should I pick that index in my answer or not. So whether I should pick that index in my answer or not. And then we will move to the second index and will think whether I should pick that index in my answer or not. And then we will move to the third index and we'll think whether I should pick that index in my answer or not pick that index in my answer. So we are repeating the same thing, picking and not picking, picking and not picking, picking and not picking. So idea of recursion is coming in our mind because we are repeating the same thing. So for the first index, for the zeroth index, we have two choices. For the first index, we have two choices. For the second index, we have two choices. And if we multiply three, these two, we get 2 to the power 3. So we can say that for n number of elements, we will have 2 to the power n subsequences. Let us now look at the tree tracing for the pick and the non-pick method. So I have this function and I have passed the arrays index and our answers array as an argument. So we will start from 0th index and our answers array will be empty. So for the 0th index, I have two choices. Either I will pick the 0th index and move to the first index, or I will not pick the 0th index and move to the first index. So if I pick the 0th index, I will get 1. So firstly, the left subtree will be executed. So if I'm at the first index, again I have two choices. Either I will pick the first index and move to the second index, or I will not pick the first index and move to the second index. If I pick the first index, I will get 1 and 2. Now again we will execute this first. So this function. So if I'm at the second index, again I have two choices. Either I will pick this index and move to the third index, or I will not pick this and move to the third index. If I pick the second index, I will get 1, 2, and 3. Now we will execute this. So when we execute this, we find that there is no third index in the array. So this will be one of our subsequence and we return. When we return, we will pop this 3 out and then we go down to this function. And when we go down here, we are not picking anything. So we'll directly pass this 1, 2 over here. So again, if the index is 3, this will be one of my subsequence. So this is completed. Now we will return. Now we will again return and pop 2 out. Now we are having with 1. Now if we don't pick anything, again this one will be passed down here. So now here, if I'm at the second index, again I have two choices. Either I will pick the second index and move to the third index. I will not pick the second index and move to the third index. If I pick the second index, I will get 1 and 3. So if the index is 3, this is one of my subsequence. And if this is completed, we will return, and we'll pop the 3 out and we'll pass 1 over here. Again, we are getting 3, so this will be one of my subsequence. Again, this is completed, so we return, then we return, then we return. Then we go to this function and pass this in this function. So now if I am at the first index, again I have two choices. Either I will pick this index and move to the second index, or I will not pick this index and move to the second index. If I pick this index, that is the first index, I will get 2. Now I am here. Again two choices. I will either pick this and move to the third index, or I will not pick this and move to the third index. If I pick this, I will get 2 and 3. So if this is 3, this will be one of my subsequence. If I will, if I don't pick anything, this 2 will be passed down here, and this will be one of my subsequence. We have completed here, so we return, and then we move down here. So this will be directly passed down here. So if I'm at the second index, again I have two choices. Either I will pick the second index and move to the third index, or I will not pick the second index and move to the third index. If we pick the second index, we get 3. Then we return and pop this 3 out and move here directly, copy it here. So we have successfully traced the tree for printing the subsequence. So once we have finished tracing this function, let's now quickly go into the code editor and code it. So I am at my code editor. So let's now code the subsequence program. Hashtag. So our function name will be subsequence. What parameters? We are passing an index, an array. So this will be our array numbers. Then we'll also be having a array in which we will store our answer. We are passing it by reference. So let's now look what we were doing. So look at this tree. So what we were doing. So for the each index, what we are doing, either we are picking that index and moving to next index, or we are not picking that index and moving to next index. So firstly we pick. So how we pick? So to pick, we will push ARR of index. Yes, index. So we'll push it in our answers array, and then we call a function, and then we increase the index by one. We'll pass array in our answers array. So this is for picking. Now we will now the recursion will go in this, and then when we return we will pop back the index, and then we again call this with index plus one, then our array null. So this call is for not picking it. So we are firstly picking. So to pick, we push it back in our answers array, and for not picking, we pop back. So we pop the selected index. So again, now look at the tree tracing. So we keep on picking and not picking until we reaches the index that is equals to the size of the array. And at that time, we print our answer. So if if index, so this will be our base condition, equals to the array size, then what we are doing, we are printing our array, and our array is ARR, and then we return. So let's now quickly code for the printing. So void print array, we will pass an array. So what for pro id rr. So now cout, sorry, cit, then so this will print our array. So let's now take this example only. So take 1, 2, and 3. So let's now pass. So we will pass. We will start from 0th index. We will pass our array and the answers. So let's now create the answers array. Let's now run it. So this is ARR was not declared. Oh, sorry. It was V, not ARR. Yeah. Oh, what is printing? Sorry. Here I am written ARR. Should be answers array, not the AR, not the original array. Yeah, look. So all the subsets are printed. So let's now confirm it in a. So now see order is also same. 1 2 3, then 1 2, then 1 3, then 1, then 2 3, then 2, then 3, then our empty array. So this is the code for printing the subsequence. So we are firstly picking it, then we are not picking it until this base condition is reached. So we have successfully written the code for the subsequence. So let us now copy this and go into our question. So what this question says. So the question is subsets. So we are given an integer array nums of unique elements and we need to return all possible subsets. And our solution set must not contain duplicate subset. What does this mean? This means that instead of printing subsets, we can print subsequences. So 1, 3 and 3, 1 both are treated as same. So we can print subsequences. So let us now paste our function here. So we need to return the vectors of vectors. So let's create vectors vector. Okay, so we have already used answers. So let us name as answer 2. And what? Then we will call our subsequence function. So what parameters? It will firstly we pass the 0th index, then our nums array, and let me actually zoom if you are not able to see. Yes. So our nums and then our answers array. So we have not created it. So let's create our answers array, a vector. So answer will be passed, and we need to pass this answer to. Let us so write down here. So vectors vector will pass it by reference. So earlier we were printing this. This time we will push this in our answer to array, that is 2D array. Pushback with answer. So let us now return answers to. I think everything is fine. Let's now run this. What error this? Oh, sorry. Actually, we have not wrote. So we need to write in these two functions also answers to. So let us now run again. Oh, sorry. These are small errors. Yes, so test cases are accepted. So both test cases are accepted. Let's now submit it. Yes, so it is accepted. So let us now look at the second method for printing the subsequence. So in the previous pick and not pick method, we were looking from this array's point of view. And that is, we are going to each and every element of this array and asking whether I should pick it or not, pick it or not, pick it or not. But this time, we will be looking from the answers point of view, that is the subsequence point of view. So this time we will ask what all things I can put at this index of my answer, what all things I can put at this index of my answer. So let's now begin. So so let's ask what all things I can put at the 0th index of my answer. So I can either put the 0th index of this array or the first index of this array or the second index of this array as the 0th index of my answer. So I can put at the 0th index, the first index or the second index. So if I pick the second index, it will be 1. If I put the first index, it will be 2. If I put the second index, it will be 3. So now again, listen very carefully. Now look at this. Now, what all things I can put at the first index of my answer if I have already taken the 0th index from this array. So if I have already taken the 0th index from this array, I am left with two choices. That is, either I should take the first index or the second index. So now I have two choices. Either I can take the first index or the second index of this array as an first index in this answer. So if we choose first index, we get 1 and 2, and if we choose second index, we get 1 and 3. Now again listen. What all things I can put in my first index of my answer if I have already taken the first index of the array. So if I have already taken the first index, I am only left with one choice, and that is to pick 2. So if I choose 2, then my what will I get? I will get 2 and then 3. So now again, look here. So what all things I can put in my first index if I have already taken the second index. But wait, if we have already taken the second index, we have left with no choice. So we have no choice. So now look for the second index. So what all things I can put in the second index of my answer if I have already taken the first index in my subsequence. So if I have already taken the first subsequence, I am left with only one choice to pick 2. So I will pick 2, and if I pick 2, what I will get? 1, 2 and 3. Now look here. So now what all things I can put in my second index if I have already taken the second index. So if we have already taken second index, there is no choice left. So there is no choice. Similarly, we have already picked the second index, so no choice. For this, we also have no choice. So now look here. So if we have already picked the second choice, second index here, then this also have no choice. So now we have successfully printed all the subsequence. So let us now look at the tree tracing for the second method. So I have this function and I have passed the index. So this array index, and we have our answers array. So we start with our index 0 and our answers array is empty. So if I'm at the 0th index, what all choices do have? So if I am at the 0th index, I can either choose this index or this index or this index. I have three choices. Either I can pick the 0th index or the first index or the second index. So if I'm at the 0th index, so I can either pick that 0th index and move to the first index, or I can pick the first index, move to the second index, or I can pick the second index and move to the third index. So if I pick the 0th index, that is 1, what will I get? I get 1. So firstly, this will be executed, the left subtree. So now if I'm at the second index, so here, then again, what choices do I have? Either I can pick this index or this index. So I have two choices. So either I can pick the first index and move to the second index, or I can pick the second index and move to the third index. So if I pick the first index, so what will I get? I will get 1 and 2. So now this will be executed. So now if I'm at the second index, what choices do I have? I have only one choice. Yeah, that is to pick the second index only. So I have only one choice. So I'll pick the second index and move to the third index. And if I pick the second index, I'll get 1, 2, and 3. Now we are at the third index, but there is no third index. So we return, and then we return. Then we move to this function. So now look, for this function we have picked 2. So what we get? 1, sorry, we have booked the second index, and second index is 3. So we get 1 and 3. So now we have reached the third index. So there is no third index. So we will return. Then we will return and look for this choice. So now for this choice, we have picked the first index. So if we have picked the first index, we will get 2. Now if we are at this, now if we are at the second index, so what choices do I have? I have only one choice there, that is to pick the second index. So we'll pick the second index, move to the third index, and if we pick the second index, we get 2 and 3. So now if we are at third index, now we cannot move further, so we return and then we look for this choice. So for this choice, we have picked 2, so we'll get the second index. So we will get 3. Now if we are now again we are at 3, so we will return and our program ends. So this is the tree tracing for this for the printing the subsequence with the second method. So let's now quickly go into the code editor and code this. So I am at my code editor. So let's now quickly write the code for printing the subsequence with method 2. Void subsequence. So this will be a second function. What all things we are passing? We are passing an index, our original array, pass it by reference. Then we are also passing our answers array. This will contain all the subsequences. So what we are doing at each step. So let's now look at the tree. At each step, what? We are looking for all choices from index till the size of array. From index till the size of array. From index till the size of array. Yes, and what we are doing? We are pushing that index, and when we return, we pop that. So let's now. So we will run a loop till I index till array's size. Increment it every time. So what we are doing? We are pushing. We will push our answer. What we will call our subsequence to with I plus 1, not index plus 1. Answers array, and when we return, we will pop it. So we keep doing these three statements at every step. So till how much, at what time we need to do this? Until the index reaches 3. It means until the index reaches the size of array. So if index array size, then what? Then what? Then we just return. And where I am getting my answer? So look, we are getting a subsequence at every step. Look, at every function call, we are getting our subsequence. Look, so we are getting our answer at every step. So we will print our array at every function call. PANS answer. So I so we have successfully written our code. So let's now quickly check whether this is done. Just we need to change this to 2. So let's now run it. What error it is giving? Actually, that is a compilation error. So again run it. Yes, now look. So we have successfully printed all the subsequences using this second method. So let us quickly copy this and try putting this in our question. So to check whether this also works. Let's now paste this. Now again we need to change. So everything here everything is fine. Just we need to change this to 2. We need to create a vector of vector for this function. So let's create here. So vectors of int, we will pass it by reference answers 2. Each time what? We will, instead of printing, we will push this in our answers to array. These vectors of vectors. Push our answer. Um, I think this will give the correct result. So let's now run this. Again, it is giving sequence to I plus, oh sorry, again, same mistake. Look, we are doing the same mistake. We now passed answers to, yes, so this is accepted. So let's now submit it. So in this, this has also passed all the test cases. Let us now look at another method for printing the subsequences, and this method is known as the bit masking. The method says bit, so we will be going to use the bits print the subsequences. So what we know? We know that the maximum number of subsequences that can be formed using n number of elements is 2 to the power n. And for this array, we have n is equals to 3. So maximum number of subsequences can be 8, that is 2 to the power 3. So let us now observe. So, so this 8. So let's now write the numbers from 0 to 8 and observe their bits. So firstly 0. So 0 in binary can be written as 000. So we are taking only 3 bits. Why? Because we have only 3 elements, that is n is equals to 3, and that's why we are only taking 3 bits. So for 1 in binary we can write 1 as 001. 2 in binary we can write as 010. 3 we can in binary we can write 011. Similarly 4 100, 5 101, 6 110, 7 111. So we have write the first 8 numbers and their corresponding bits. So let us now, in bit masking, what we do, we assume two things. So we assume that 0 means we will not pick and 1 means we will pick. So we have taken here three bits. So each bit represent the corresponding index of this array. So this bit represent this index. This bit represent first index. This bit represent the second index. Similarly, this bit represent the zeroth index. This first index. This the second index, and similarly like that. So let us now start from 0. So we are assuming that 0 means don't pick and 1 means pick. So look here. So 0 means we will not pick anything. So 1 means we will not pick the first index. Again 0 will not pick the second index. So what we get our answer? An empty set because we have not picked anything. Now look here. 0 means we will not pick anything. 0 we will not pick anything. 1 means we will pick the second index. So if we pick the second index, what we get? We get 3. Now look at 2. So 0 means we will not pick. 1 means we will pick the first index. That means 2. And 0 means we will not pick anything. So we are only picking the first index, that is 2. So we will get 2. Similarly for 3 we will not pick 1, then we will pick, then pick. So we are picking the second, so first and the second index, that is 2 and 3. So we'll get 2 and 3. Look here. So the we are only picking the zeroth index. Zeroth index is 1. So we will get 1. Similarly, look for 5. Well, we will pick the zeroth index, not pick the first index, then pick the second index. So we are picking only 0 and second index, that is 1 and 3. Similarly, for 6, we are picking only 0 and first index, that is 1 and 2. Similarly, for 7, we are picking all the indexes. So we get 1, 2, and 3. And if we look closely here, so we have printed all the subsequences. So from this, what we observe that if we write the if we write the numbers from 0 till 0 till 7, that is first 8 numbers. Then, with the help of their corresponding bits, we can print the subsequences. So before going to the algorithm of bit masking, so let me tell you how to access the bits using bitwise operation. So one method you already might know that you can manually generate all the bits using the loops and division by dividing this 3 by 2, keep dividing it by 2, then you can manually generate these bits. But I'll be telling you how to access these bits using the bitwise operation. So 3 in binary can be written as 0, 0, 1, 1. I am taking 4 bits. So let us now how to access it. So firstly this, what will be 3 right shift 0? So 3 right shift 0 means we will shift all the bits of 3 by how many step? 0 step. So we will shift all the bits of 3 towards right direction. How many times? 0 times. 0 times means I will get this only. So now 3 right shift 1. What does it means? We will shift all the bits of 3 towards right. How many times? One time. So if we shift all the bits of 3 towards right by one step, what I will get? I will get 0, 0, 1, and this one will be removed, and then an extra 0 will be added. So I will get this. So this one is removed and an extra 0 is added. So I get this. So if I perform 3 right shift 2, it means shift all the bits of 3 towards the right direction by 2 steps. So if I shift it, these two, that is these two ones will be removed and I will get 0, 0, 0. So now look carefully. So if I perform an AND operation. So if I have perform an AND operation with 3 right shift 0, it means I am performing the AND operation with this also. So what I will get? 1 1 means 1. Now look here. If I perform an AND 1, this operation with 3 right shift 1, it means I am performing the AND operation with this beats. So what will be 1 1 will give me 1. So now look, if I perform the AND operation of 1 with 3 right shift 2, it means I am performing AND operation with these bits. So I will get 0. Now observe, for 3, 0, 1, 1, and I am also getting 0, 1, 1. So by observing, what we can say that for this operation, 3 right shift 0 and 1, 3 right shift 0 and 1 will give me 0th bit of 3. 3 right shift 1 and 1 will give me first bit of 3. 3 right shift 2 and 1 will give me second bit. Yes, the second bit of this 3, and that is 0. So what we can say, 3 right shift j and 1 will give me what? It will give me the jth index of 3. So let us now conclude. So for I right shift j and 1, what will this give? This will give the jth index of I. So this will give me the jth index of I if I do this operation. This will give me jth bit of I. Yes. Let us now look at the algorithm for printing the subsequences using bit masking. So in bit masking, what we were doing? We were generating all the numbers till 2 to the power n. So where n is the number of elements in our array. So what we are we are generating the numbers till 0 to 2 to the power n, actually minus 1. This will not be included. 2 to the power n is not included. So we will generate a number from 0 till 2 to the power n minus 1. So minus 1 is not here, written here. So minus 1. So after that, what? We will run another loop that will run from 0 to array size. So this loop is run to access all the bits of this array. So after that, what? We will perform this arithmetic, so this bitwise operation that I have already told. So what this does, this will tell you the jth bit of I. This will tell you the jth bit of I. So jth bit of I will be stored in num1, and then I will check if that num1 is 1. 1 means we will pick that index. So we'll push the ARR of j in our answer. So this is my algorithm for the bit masking. So let's now quickly go into the code editor and code this algorithm. So I'm at my code editor. So let's now quickly write the third method for printing the subsequence. So void subsequence. So this will be a third. We will just a only pass just our array. So what we are doing? We are running a loop less than 2 to the power n. Let's now calculate 2 to the power n. So 2 to the power n is the maximum sequence we can have. So 2 to the power n. So n is a size till the max sequence. We will again run the loop. This time j should be the size. Now j plus 2. Each time what we are doing? Look at the algorithm. We num1 will do a right shift to j and do an AND operation to access the last bit every time, and then we check if this num1, so, if this is equals to 1, so we need to pick that index. So we will push that in our answers array. What? ARR of j. We are pushing it in our answers array, so we need to declare our answers array. Says after completing, we will print our array. This we are answers array. So we have successfully written the third method. So let's now quickly check whether this is running fine. We need to only pass. Let's now run it. So okay, yes. So this is giving the correct result. That is 1, 2, 1, 2, 3, 1, 3. So all the 8, this is an empty subsequence. All 8 subsequences are printed. So let us now copy this and paste this in our previous question of subsets to check whether this method also works for all test cases. So let me just zoom it. Yes, so again we need to change something. It is instead of print arrays answer, we need our answers to dot push back. Need to push our answer, and if we have we need to create answers to here. Does of so int will pass it by reference answers to, and just one more thing to change in this line. So we don't need this answer. We don't need the 0th index. So and again this should be 3. Let us now run. So yes, it is also working. So let me quickly submit this. Yes, so this method also works. So let us now look at the fourth method for printing the subsequences. In this method, we are going to use the nested loops. So the outer loop will run in my array and my inner loop runs in my answers array. So let us now look how this method works. So now look, initially my answers array have only one element, and that is an empty set. So this inner pointer will run only one time because my answers array has only one element. So look what we do. We copy this, copy this and store this in a temporary array, and then we push this one in that array. And then we push this in our answers array and we'll move this pointer. So now again, this time, this time my answers array size is 2. So now this pointer will move 2 times till here. So let me mark it. So this time this pointer will move till here, till this element. So now again look, we will copy this and then we will push this. We will copy this and we will push 2. And then we will push 2 in our answers array and then we will move the pointer here. Now again we will copy this and we will push 2. We will copy this and we will push 2. Then we will push this in our answers array. Now we have reached here. So we will move this pointer and this will return 0. So now this time my answers array size is 4. So this time this pointer will move till here. So let me quickly mark it. So this time this pointer will move till here. So now again listen. So we will copy this, we will push 3 and then we will push 3 in our answers array and then we will move this pointer again. We will copy this, we will push this in this array and we will push this array in our answers array and then we will move this pointer. So again listen, this time we're going to write our algorithm. So what we will copy this and store this in a temporary array and then we will push this 3. So we will copy this and store it in a temporary array and then we will push this 3. So now here we are storing the jth index. So this is the jth pointer. We are copying the jth index means jth answer. We are copying the jth answer and then we push the ith index. This is ith pointer. We are pushing the ith index in my temporary temporary array. And then what we push this in our answers array. So we will push the temporary array in our answers array and then we will move this pointer. Now again look, we, we will copy the jth index in a temporary array and then we will push the ith index in this array and then we will push this temporary array in our answer. So now look, we have successfully printed all the subsequences and this is the algorithm. We will store the jth answer in temporary array and then we will push the ith index. We will push the ith index of my given array in the temporary. So and then we will push the temporary array in my answer. So this is the algorithm. So let us now quickly go into the code editor and code this algorithm. So now I'm at my code editor. So let's now quickly code the fourth method for printing the subsequence. So subsequence will only pass our original array. So now look at the algorithm. So we will run two loops. First in the array. Then second loop is for answers array for j0 ans. So second loop is for answers will be the size of the answers array j plus. Actually we cannot directly write answers dot size because we are keep changing it every iteration. Answers should be only size. J should be less than size. So let's now create our answers array. So it will be a 2-day array. And initially we have only one empty subsequence. So now what we are doing at each step, firstly we will create a temporary array in which we will put the jth index of I, then we will push the ith, keep pushing the ith index. Sorry, actually I've written wrong, it should be answers. And then we push back the temp, and we can print every temp here to get our answer also. So let's now change it to fourth method. Yeah. So let's now check. Subsequence 4 was not declared. Sorry, it should be 4. Yes, so now look, every subsequence is printed. So just the empty subsequence is not printed. We can directly print it, just printing it here only. So it doesn't matter only. So we have got all our subsequences. So let us copy this and again paste it in our previous question. Check whether this method 4 works or not. So let me zoom it. Sorry. We paste it here. So again I need to change vectors of I and the answers too. This time actually we don't need it. We are already getting our vectors of vectors. So just remove this, and for here let us just answers to, we are already getting it. So let us now actually directly return our answer. Just directly return. Let's directly return. Just remove this. So now I don't need this. Also don't need this. I also don't need this. So just we can directly return our answer. So we need to also change the return type. That is does of int, we can directly return subsequence. So 4, we're only passing our norms array. So let us check. So answers, sorry, this should be. So yes, it is running. So let us submit this to check whether it is working. So yes, this method also works. So before we wrap up our session, I want to briefly mention backtracking. So backtracking is an algorithmic technique that uses a brute force approach to find all possible solution to a problem. So what is backtracking? So backtrack is an algorithmic technique that aims to use a brute force to find all solution to a problem. So backtracking is used when you have multiple solutions and you want all of those solutions. So in backtracking, we try different options and undoing them if they lead to a dead end. And when a dead end is reached, the algorithm backtracks to the previous decision point and explore a different path until a solution is found. So this is the algorithm, and that is backtracking tries different options to find all possible solutions to a problem. And if an option leads to a dead end, the algorithm reverts the decision. And when a dead end is reached, it goes back to the previous decision point to explore alternative paths until a solution is found. Due to the time constraints, we won't be covering the backtracking in detail today, but I encourage you to explore it on your own. It's a very powerful concept used in problems like NQN problems, Sudoku solving, and more. So that's all for today's session. Thank you for listening. And if you have any questions, feel free to ask in Hackslash committee.